This video takes you through the presentation for Tuesday. These stampers should have already stamped the assignment for 3 and your stamp sheet. If that has not happened, please pause the video and do it now. If you come to me tomorrow and say you didn't get stamped because the stamper didn't stamp you, I'm going to tell you it was your fault and you can take the late grade. Also, make sure your notes for 4 are out and ready to be taken, as we will go through them after we check the assignment. So, problems 1 and 2 are on the board. Make sure you are checking. You may pause the video at this time. If you have any questions, please ask the people around you. 3 and 4 are on the board. If you have any questions, please ask the people around you and pause the video as needed. Problems 5 and 6 are on the board. Please pause the video as needed, and if you have questions, ask the people around you. And 7 and 8 are on the board. If you have questions, please ask the people around you. We will go over problem 8, so you can pause for people to check 7, and the rest of this is going over 8. So problem 8, my domain is my x's. My x-axis is the one that goes side to side. These arrows mean that this function is going to keep going on and on and on forever to the left, but it will stop at 1 on the right. So I've drawn down here, I have 1, and it's going to go forever to the left. So my x's are getting less than or could equal 1. It could equal 1 because we do not have an empty bubble. So pretty much what you do, if you have a regular function, unless you see an empty bubble, assume that it's filled. Then my y's are on this axis, and my y's are going all the way up and all the way down. Remember, those arrows mean they will never stop moving. So this arrow right here will never ever stop moving. So that is why my range is all real. So, if you have not already, now is the time to get out your notes. While you're doing that, I'm going to remind you of a couple quick things. Today, we are going to introduce all 3 functions. Remember, I told you this is an intro to all of the functions unit. So, we're going to look at linear, quadratic, and exponential, and then we're just going to play a game. So, there is no assignment today, which means if you have anything 4-1, 4-2, or 4-3, today is the day to catch up on it. It also means if you're in my 4th period or someone else's 4th period, that you need to not be a jerk if you've already finished everything and find something else to work on. Don't make us regret not giving you an assignment today and instead playing a game. If you got a retest review yesterday, remember retest for Unit 3 is due on Thursday. But also remember we don't have school next Monday and we have the PSAT next Wednesday. So you really have 1, 2, 3, 4, 5 days left. So basically a week to get that retest taken care of. So we're going to look at this introduction to functions day real quick. So in algebra we study 3 major types of functions. They are all shown below. So the first one is linear. Linear is what we've been looking at. Linear is what we will spend the most amount of time on. So linear is the equation y equals x. So what do you notice about this graph? Well, you might notice that it's a line. Because it's a line, it's continuous. Because it's continuous, you might also notice it goes through, or you just randomly, you might notice that it goes through the origin. And you could also maybe notice that it's increasing. So as you read it from left to right, your x's are going up and your y's are going up. So this line is increasing naturally. We've asked you to identify the following characteristics. So we've already said that it's continuous. There's not an arrow shown, but these do extend in all directions. And so for this, what the heck? Okay, sorry about that. So for this, the arrows mean that it's just going to keep going on and on and on forever. So my x's go everywhere from the left and everywhere to the right, and they go all the way down and all the way up for forever. So that's why it's all reals in both. The second one is quadratic. We use the expression or the equation y equals x squared to see a quadratic graph. This is my quadratic graph right here. So you might notice a couple of things. First, that it looks like a U shape. It's not straight, but because we do have continuing lines, we don't have lots of dots, it is continuous. Okay, and you might also notice that this too goes through the origin. So this one would also be continuous because we don't have just a bunch of dots everywhere. My domain, my x's go everywhere to the left, everywhere to the right, and they're going to keep going forever and ever and ever. So my domain is all reals. And for my range, my y's go all the way up, but they stop at 0. So my y's are everything greater than or equal to 0. It could also equal 0 as well. And then for exponential, if you notice, this graph kind of looks like a ramp, like a skateboard ramp. You might see it as something else. I'm not really sure at this moment. Nothing's really coming to me. This one is also increasing as we read from left to right. This one does not go through the origin, but is also continuous because it doesn't stop and it doesn't just have a bunch of points. So, couple characteristics, it is continuous. The domain for this is going to be all reals because it extends all the way out to the left and will continue all the way out to the right. And then my range is really hard to see, but what happens is it goes all the way up for forever, but it only goes really, really close to 0, but cannot actually equal 0. We'll talk about that when we go more in depth with exponential functions, but for this one, your range is going to be greater than 0. So they ask us to identify what type of graph this is, if it's linear, quadratic, exponential, or neither, and then identify the domain and range. So this one is a U-shaped, which means it's going to be quadratic. My domain is my x value. So my x's go from 6 over to 7. And remember, if you want to, you can draw that line in between to help us remember that it's going with the x-axis. So my x's go all the way out to -6 and then all the way to the right to +7. At -6, there is a filled-in bubble, so I'll put a line under the inequality. But then at 7, we have an open bubble, so there is no value at 7 on the x's. Then for my y's, I go all the way, remember this is up and down. So this time it's a little bit different because this domain and range, or this range specifically, does not use the 2 endpoints. Remember yesterday we used the y-axis. So I'm using this y-axis, and I'm saying on that y-axis, this function goes all the way down to -8, and it goes all the way up to 4. So I'm using the axis, not just the points. So my range is from -8. At -8, I have an open bubble, so I'm going to put no line under the inequality. And it goes all the way up to 4. So again, if you want to draw that line, your vertical range, your y-axis, goes all the way down to -8 and all the way up to +4. Now this one we've seen a couple times this week. This is a linear function because it is just a straight line. My domain, if I follow this x-axis, I go all the way out to -5 and then it keeps pushing to the right. So I have my x and my -5, and I need to figure out on the x's if I go to the right, if that's greater than or less than. So as I follow this, I am at -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. So these are getting greater than. And if I erase this, I can see my bubble was empty. So I don't put a line under the inequality. Then for my range, it goes all the way up the y-axis to 8. And then fills in the rest of the y-axis by going down. So on the y's, if I go down, that's 7, 6, 5, 4, 3, 2, 1, 0, -1, -2, etc., which means it is getting less than, and the bubble is still empty, so I do not put a line under the inequality. So we have a couple of quick ones on the back. Problem A, this doesn't really look like anything. It could be exponential if we weren't really sure. So if you wanted to say it's exponential, that would be totally okay. My domain on the x-axis, we're over here at 1, and we're going that way for forever. So x is getting greater than or could equal 1. And then my range, I'm down at 0, and it's going to keep moving up. So my y's are going to be greater than 0. Part B, this one is not a function. It kind of looks like it could be a line, but because it is discrete, it's not actually going to be a function. Because it's discrete, it's not going to be linear, quadratic, or exponential because as we said on page 1, they were all continuous, and this is not. So, domain, my x values are over here at -2. And if you notice, all of these dots have the same exact x value. So, our domain is x equals -2. And that's the only x value for the domains that we have. Then the range has been listed here because you need to list all these y values. -4, -3, -2, -1, 0, 1, 2, 3, 4, and 5. So we listed those for you for the sake of time. Okay, when I look at part C, this is a straight line, which looks like what we've been doing this week. This one, with my domain, with my x-axis, if you look, it keeps going to the left and keeps going to the right, so that's going to be in all reals. And then with my range, it's going up for forever, down for forever, so that is also all reals. Remember, you can write the word all reals as well if you would like, or you can do the R with a double line. Part D, this one is going to be quadratic. It's just been turned on its side. So domain is the x-axis. Now my x's start here at 0 and push to the right. So my x's are greater than or equal to 0. And my range goes up, and this arrow means it's going to keep going on up. And then goes down, and this arrow means it's going to keep going down. So my range is going to be all reals because there are no stopping points on the y-axis. E is also quadratic. This time, my x's go all the way to the left, all the way to the right. So this is going to be all reals. My range goes all the way from the bottom, but does not go all the way to the top. It stops at 2. So from 2, it's going down. So my y's are less than or could equal 2. And part F, this is a neither because it is not continuous, so it is none of the graphs. My domain, I'm going to list out all these x values. So I have -5, you want to write small, -4, excuse me, -3, excuse me, -2, -1, 0, 1, 2, 3, and 4. And remember, with discrete domain and ranges, we write the squiggly lines. Then for the range, I'm going to write it underneath my y's. I have 0, 1, 2, 3, 4, and 5. And remember, if anything repeats, x's or y's, you only have to write it one time. So you don't have to put 0, 1, 1, 2, 2, 3, 3, 4, 4, and 5. You can just write it one time. So as you're about to see on the rest of this PowerPoint, the rest of class is going to be spent on an activity. You should not have any homework tonight because you should be able to finish the technology activity in class. However, if I hear that you did not use this activity wisely or people were on their phone, then I will make sure you have a makeup activity tomorrow in addition to your assignment. Be good, like I know you can. See you Wednesday.